Yeah, so hello everyone, welcome to Devour. We started a bit late, just had a bit of a technical glitch here and there, but we managed to sort that out. Um, so basically, today's session of Devour, we're basically going to be talking about smart contracts in Solidity, how to write them, and how to deploy them, basically. If you've been with us during the Telos and Memory Hackathon, you'll find that we've been able to discuss this topic throughout the bootcamp talking about Solidity smart contracts, specifically in the Telos EVM. But it's basically the same thing, but now we're just showing you in terms of how it can be interacted with in multiple EVM compatible blockchains and Ethereum as well. So one of the key things we're going to talk about that's slightly different is I'm going to go into what smart contracts are specifically, why we use them, and how we go about using them during day-to-day operations, maybe as a Web3 dev or a smart contracts writer, auditor, just some key things that you may need to know. So first things first, just a brief history of what Solidity is as a programming language. Basically, it's the main programming language that we use to write smart contracts in the Ethereum ecosystem. And it's basically based on JavaScript and Python heavily, and I think C++ as well. So what you'd find is the reason for this is it makes it easier for Web2 devs to come into the blockchain space because they'll find some similarities between what we have in Solidity to what they've been working on couple of for the maybe past few months, years, depending on the experience. So there are lots of similarities in that sense. Then another thing to note is that this also makes it easier for people who have, don't necessarily have a development background. You can actually become a Web3 dev straight from whatever other sphere of life you're in or any other career path and actually learn how to write smart contracts in Solidity pretty simply and basically you'll be able to start as soon as possible and actually get a number of opportunities in the Web3 space as well. So those are just some of the key things in terms of what Solidity is and why it's key specifically in the blockchain space. So I've briefly talked about what EVM is. So for those of you guys who don't know, EVM basically stands for the Ethereum Virtual Machine. So you'll find that it's basically the runtime environment for all of these smart contracts. So as for smart contract to be run and executed, it needs to function in a particular environment, and that's what we refer to as the Ethereum virtual machine or the EVM itself. And the smart contract itself is basically just a set of instructions that is now stored or as a protocol on the blockchain that is used for to do multiple functions as well. You can have smart contracts for minting specific types of tokens. You can have a smart contract that interfaces with your application or your decentralized app. You can have smart contracts that help maintain things like decentralized exchanges for tokens or liquidity pools as well. So those are just some of the key functions of how smart contracts can be used or implemented. And I think a new use cases in terms of climate change, you find that a lot of projects that are functioning using carbon credits and seeing how they can tokenize that are actually being implemented on the blockchain as well, which I think is a good initiative. So those are just some of the uses that we can have. So I'm gonna briefly just take you through how to write a smart contract on Solidity from scratch and also through a number of tools that we have available. Then another thing is also just to briefly discuss the syntax of how Solidity works. I won't go too in depth because there's a lot of information, but just some basics that you may need to know just as you're writing your first smart contracts again. So what I'm gonna be doing is I'm gonna use something called Remix, which is basically an IDE. It's a development platform. You can install it in your PC, but what I'm gonna be using is the web version. Sorry about that, I seem to be having a cold. And One of the key things is that Remix help you do is actually compile and test the deployment of your smart contracts. So this is important because basically lets you know if what you're doing works or it doesn't in a very lightweight and simple way, as some of the key focuses of why Remix works as an IDE. You can still code in Visual Studio or any other code editor that you like using, but for today I'll just use Remix just to showcase a couple of things here and there as well. I'm gonna be using the native or the test chains Remix gives us access to. I'm not gonna go through connecting MetaMask just yet, but I just want to show you simply how a smart contract works, how it operates, and some key things that you may need to take note of as well. So maybe as we continue, I'm basically just going to talk about the syntax of a smart contract. So let me go ahead and share my screen so you can be able to see my IDE. As always, if you have any questions, feel free to shoot them in the chat and we'll be good to go. So as you can see here, I've created a workspace called dev hour and a basic smart contract called token.sol. So Sol is a file extension for a Solidity smart contract, as we can basically see here, the highlighted file. So any Solidity smart contract has that specific extension. So I'm going to go through the syntax of how to write a basic smart contract. So what we have here is I've not added anything into the contract just yet. Just want to describe a couple of things that you may need to know. Firstly is in the first two lines. So this SPDX license identifier being MIT, then the pragma solidity, just information about the smart contract. This solidity basically talks about the version of the solidity compiler we want to use to compile this particular smart contract, which is important to state because there are many multiple versions of the solid of the solidity um, compiler per se. So what happens is I'm just going to talk about the science. So I'm just going to copy paste this and basically show you. So you can either say you want the smart contract to run a solidity version that is basically 0.8.20 or higher per se, or I can basically specify that I want. You can also specify like so that you want it to be equal to or greater than 8.2. You just want it to be greater than, or maybe you want it to be less than. You can also put it as a range. Where can we do that? 8.0. So let me say greater than 8.0, but less than 0.9.0 as such, just in terms of different versions that we can set for what we want to use. But for now, I'm just going to keep it as is. Anything higher than 8.20 will do, or this specific version as well. So that's the reason for that. So this is basically how we define that this is a contract. It's a keyword statement. The same way you come up in Java and you say maybe public or something like you're trying to create a class for a person or a human. So think of it, it does not work exactly like a class does in Java or JavaScript or any other programming language. Let me just make that specifically clear because people use that example saying that a contract is basically like a class. But there are functions and things that a contract can do that is not the typical behavior of a normal class file within any other JavaScript programming language. There's a that unique attributes that Solidity has that we're going to be getting into over time as we continue. So the other thing I'd also like to mention is briefly in terms of just talking more about smart contracts themselves specifically. So I've talked about the specific version. Now let's go into the specific data types that we have in Solidity. So these are basically like how you set up the variables you define, the specific data types that you want associated with them. So I'm just going to type in here a few examples, then describe more about them. I think the first data type, which is pretty straightforward, that anyone knows about, is the Boolean data type. I think as we can see here. So I say bool, then I say status. So for this one of simple, it either takes a true or false value. Pretty straightforward like in any other um, programming language. Then the only difference with Solidity and maybe Java is for Solidity, when we look at integers, we can basically use two different types of integers. There's what we call the uint integer. Maybe I'll say uint 256. Then I'll do int 256. Then I'll say uh, p. Then I'll say number. Then I'll say number 2. So an interesting thing about smart contracts is that everyone knows the challenge about gas fees. And for those who are new to the block Web3 space, you know there's a challenge in terms of how much it costs for you to deploy a smart contract and for users of your application to interact with it. And what drives gas fees to be higher is usually the amount of data that you're sending as part of a transaction or the amount of data that you're storing in a contract per se. So an interesting thing about it when you're doing setting up integers in Solidity is that you can set up the size of memory you want to use for specific number. So for this one, I say uint 256. I'm basically saying this is a number I want to store in a space of 206 to 256 bits. But you can reduce that based on the type of data you're expecting for this particular variable. And data management is key. So this is something that, as much as Solidity borrows a lot from C++, Java, and JavaScript, it performs kind of like uh, languages like Go, has not or any what's it called? Smart contracts in Polkadot as well, or even you're writing contracts in Rust, or maybe any code in Rust or Go, where you find that you're able to specify the amount of space you want to use for your variables. Then it's also similar to them in terms of when I say you enter, I mean unsigned uh, integer per se. So what unsigned means is it doesn't have positive or negative signs. But for normal integer, you can say this is plus or minus 10. But for number, let me just show you basically, you can say is 10. This one I can basically say is minus 10 or it's plus 10. So this is the sign that we are looking at. So this is just a normal signed integer. That's the key difference between the two of them. Another variable or data type that we use is the address. Then I say wallet. So the key and important thing for this is it's basically words or characters in that sense that you put into. So it's a string is basically like an array of characters. So that's basically how it works, similar to any other programming languages as well. Then we also have bytes. You can specify that as a data type, like so. You can do byte, and the same way I mentioned before, you can also specify the number, like you want to use like this 10, 11, 12, 13, and the likes, in case you want to store data in this particular format. Then we also do have arrays, but for arrays you need to specify like the type of the array. So for example, if I want to do an array of integers, I'll basically do int, then this particular bracket, then I say numbers. I know I'm taking some time just going through the data types. I think it's important, but that's just an example of how to do it. So when I'll do this, I'll basically just come in and say maybe one, two, three, four, like so. He seems to be having, oh yeah, he's the wrong brackets. Then let's see. Okay, yeah, okay, let me do this. Int, do uint here. So that was the issue. I was using int instead of uint. So if it's int, I need to put the specific signs as well, basically. So another data type that's key that we're going to be using is something we call a mapping, which basically helps you point uh, a key that you use to reference a data and the value of that particular key. So an example would be if I want to do, I want to map addresses like so, then I do uint to balances. So mapping specific addresses to the balances that perhaps they may have. Just as a simple example of how you can use this particular data type as well. So maybe another thing to also mention now would be there are many other things to note. There is also what we call the enum. Enum is similar to Boolean, except you specify the type of options that are there. You think of it like a biodata form. If someone asks you what country you're from, you can only pick maybe the countries that they give you as options in the drop down. So think of the drop down like an enum, a set of options that you can select, and those are the only values that this data type can accept. So if I do enum, then I say state. I can either say pending, active, or inactive. You also have to be very careful because is case sensitive. So if you put pending with a capital letter, you'll have an error if you ever want to set the value of this particular data type per se. As now, the type of, let's say this, you want to interact with objects in a smart contract. You need to define what type of data that object can have as its attributes. Then, when someone wants to create that specific object, they can basically go ahead by doing it like so. So maybe you have a struct. Let me just do this just for ease of reading. So if I create a structure called person with a name and an age. So all the time I want to create a person, I say maybe I want to create a person called Alice. I'll say that this person called Alice, their name is Alice and their age is 30. Pretty simple and straightforward. As we continue writing more advanced smart contracts, we'll do that's basically what's gonna be going on. So that was for today's focus. I just wanted to introduce the various data types and also this struct uh, functionality so that you basically understand some of the key things as we introduce you to Solidity. And I'm going to be talking about Solidity functions specifically in the next session as well. And then I'll also be talking about uh, things to do with modifiers, like do you want to have a private or a public value, and what exactly does that mean? So that's what we're going to be talking about in the next session in terms of Solidity smart contracts. For today, I just wanted to focus on the data types and also just to show you a tool that can help you basically create a very simple smart contract and deploy it. just like it said on the poster. So what I'm going to do is I'm going to erase all of this. Yeah, just leave it as empty for now. Then the next thing that I am going to do is basically go to a tool called Open Zeppelin contract. So I'm just gonna refresh this. Okay, so for this, what I'm gonna do is basically show you this is a tool that generates basic smart contracts for you. With time you learn more about them and how they work and how to interact with them. But basically it's from Open Zeppelin. Open Zeppelin is a library of smart contract templates. So just something to talk about in the Ethereum ecosystem is that number one, smart contracts, or basically Ethereum has specific standards for the type of tokens you can have in the EVM or on the chain. And you need to have to write smart contracts that fit into these particular standards. And just to add some level of consistency and stability, you would find that you don't want a situation where everyone is coming up with their own libraries or their own implementation of contracts that fit those particular standards in the EVM. So, and see, maybe we can improve these contracts like this. Maybe we can change this and say there's a particular contract here that's maybe a security vulnerability. Is there a way of doing something with this smart contract such that we can improve on it, or do we omit it? So as the version of OpenZeppelin continues, it basically grows and advances and basically makes it better. So long story short, these libraries are basically templates that you use to create smart contracts. And why do we use templates? It's because if everyone is making their own implementations of these standards, the Web3 space becomes a bit messy in terms of debugging and maybe collaborating as well. So that was also one of the reasons why. So in terms of what each of these libraries do, you learn as you continue interacting in the ecosystem. And one thing to note is also just talking about the standards here. There are lots of standards, but the three main ones that you need to know are ERC20, ERC721, and ERC1155. So ERC20, let's say, is the first one in the EVM ecosystem. This is the smart contract template that helps us create tokens, or what or most people know them as cryptocurrency. So what we refer to them is more in a technical setting is fungible tokens. Fungible meaning this token can have multiple copies of itself, all of the same value. That's how they end up being a currency. You can write a smart contract that basically mints tokens continuously, or you can set it such that there is only a specific amount of tokens that are available to the public and that can be used or traded. That's basically what ERC20 means. But then people started thinking about what are the other use cases of Web3? Can we see how we can use smart contracts to solve some of our own challenges? And what one of the key things that came up was now in the creative sector, in terms of how do I protect my intellectual property rights, maybe as an artist, or how do I go about getting value from my work? Maybe it's music, or maybe it's now my artwork. That's how we get into ERC 721. And the buzzword that made crypto popular being NFTs, or in this case, non fungible tokens, meaning that each token that is created is unique from the other one. They are not identical, and the values will also be different. So that's the key reason why this came about. So this is the standard that we use to basically mint and create NFTs. However, as time went by, people realized that okay, is there a possibility of actually making one smart contract that can help me do both. And that's how we got to ERC 1155. So with the ERC 1155, you find that you can actually use this smart contract to make both fungible tokens of cryptocurrencies and also to make NFTs or non-fungible tokens in that sense. So those are now the three main things you need to know as you're starting out. And maybe if the process of importing um, the open Zeppelin contracts is a bit confusing, it's better to use this tool because it can help you basically start up. So what I'm gonna do is just gonna create a smart contract using open Zeppelin, compile it in Remix, see if it works, then deploy it and see how we can interact with it, and we'll be done. Just as a starter into how to write smart contracts in Solidity. For the next session, we're gonna go a bit deeper. Hopefully now with a guest who will also be able to share a lot more insight in terms of how to go about this and basically things to do, things to note, as we also add more information that maybe you need to know as you start writing smart contracts. So the first thing I want to do is maybe I name my token devour, then the sign is BHR. What I want to do is, so what happens here, so this is a contract. So think about it in terms of Java. So what happens is it's extending two different uh, soul files. There's ERC20, then there's ERC20 permit. So basically this contract dev hour is also an ERC20 in that sense, basically. Then one thing to do is that just like in any other programming language, if you have a class, I'm not saying a contract is a class, but it's just a good example just to make it easier to understand, is that it has to have a constructor. When this contract is run the first time and being deployed, some data, some data or some information about it needs to be populated, and that's basically what you define here in the constructor. So you say that we are creating an basically the basic template of it in that sense. So what I'm going to do is I'm going to add a function for minting, burning, and pausing. I'm going to remove pre-minting. But these are the functions I'm not going to talk about them today, but they're also key to note. So note means it's ownable. So this smart contract needs to have an owner such that, and as you can see, it's updated in the constructor. So it creates the token, then it also creates this. So the initial owner is basically the public or the wallet address of the person who has the rights to basically interact with this smart contract. So this is a function for minting a new token. You basically say, when I'm minting or creating new tokens, who am I sending them to and how many are they going to be? Then this is now the function that we've imported from the ERC20 smart contract. So when this runs, is basically you being able to create tokens. You can also update information about this token, maybe doing some overrides and stuff like that. So that's one of the key things. And there's also pausing and unpausing in terms of the usability of this contract in that sense. Then, yes, I think that's okay. That's pretty straightforward. So what I can do is I'm just gonna copy this code and show you how it can basically run quite quickly and easily. Also point to note, always make sure to test your smart contracts. Don't just copy them like I have from OpenZapply, especially if you're building something more complicated. Make sure you understand what it is you're doing and test it out. If you're working in a team, get feedback from other members of your team, because I think it's also important to ensure the security of your contract. Because you can see, one thing that I'll talk about here is that there's no re-entrancy guard in this particular smart contract. What that is like a security feature, basically preventing someone from manipulating their transactions. So, in terms of protecting your a smart contract, it's important to take note of these things. So that's one of the key things. So after I've done that, let's go ahead and compile it. So I'm using the 8.22 version, so that's I think fine. So compile. I think once it's compiled successful, so here's our smart contract that we can now deploy. So like I said, I'll be using these. There are so many test environments that you can use. You can also connect it to your own testnet via the MetaMask injector or the Wallet Connect. But for now, I'm not going to do that. So, and here there are a number of accounts that we can use. So we need an account to deploy the smart contract. So like I said, it takes the address of the initial owner. So basically, since I'm deploying it, let me say I want to own the smart contract. So the gas limit is in terms of how much am I willing to pay for this specific transaction, which is actually important. You can also set up those gas features directly into your smart contract, but that's more advanced and things that we will be able to learn later down the line. So let's go ahead and deploy this. Yeah, successful.